Outer space, the ultimate frontier, a world above us that has fascinated man's imagination since the beginning of time. Dark, dangerous, inaccessible, but a world filled with possibilities since 1957, thanks to Sputnik and its world-famous robot Beeps, the first in outer space.
I believe that it is in man's genes, to explore and to try to understand what is out there and how is it functioning.
For 60 years, engineers have sent hundreds of robots into space. Although led by the Russians and the Americans, France has excelled in this area thanks to Arianespace and its astronauts. Using astronauts, however, is dangerous, so much so that they are being replaced by robots.
We send robots into space because it costs 100 to 1,000 times less than sending men. The robot is the means we employ to explore what we cannot observe ourselves.
In the 1960s, space exploration represented an immense challenge, adding great prestige to the nations that succeeded. The present philosophy is completely different, aimed at preparing a new world for man.
To save the human race, there is only one solution: learning to live on other heavenly bodies.
To accomplish this goal, engineers are developing incredible robots. Machines with no fear of cosmic radiation or the void of outer space or extreme changes in temperature. Almost immortal robots which never become obsolete.
A robot is definitely a machine that can be programmable. That means that can be autonomous or not.
Creating a robot that can operate 24/7 is where the difficulties begin.
The robotic systems with some form of artificial intelligence, they are appropriate and cheap ways to do this kind of exploration and to find out what is going on other planets. This will tell us a lot also about our own home.
In order to better understand our solar system, we need to send scientific robots into space. The first of these are either scout robots for making space probes, or landers which can touch down on a star or a planet and make initial on-site analyses. The next generation, the rovers, are autonomous supervehicles like Curiosity that can move around the surface of Mars, containing instruments for analyses and exploration, which enable Curiosity to discover the presence of water on the red planet. The next step will come from much stranger laboratories where engineers are developing cobots, or collaborative robots. Animal or humanoid robots will be used to assist astronauts by exploring dangerous areas and building space stations. And soon, there will be robots for cleaning up outer space and for helping man to live on another planet. The countdown has begun for the incredible adventure of the space robot revolution. Throughout history, man has always been an explorer, an adventurer, crossing continents, navigating oceans, and flying faster and higher in the sky. Today, thanks to technological progress, robots are being sent into space. And this conquest always begins with scout robots, very simple but reliable, capable of traveling millions of kilometers in space. There are two types of scout robots, space probes or orbiters, equipped with cameras for photographing the stars above them, and landers, which consist of metal boxes filled with sensors for analyzing the ground of a comet, like, for example, Rosetta and Philae, the two European mission robots studying the comet Chury. We head for the limits of outer space, 450 million kilometers from planet Earth. In the early 1990s, European engineers decided to send a probe around a comet and to deploy a lander on its surface. For a quarter of a century, 1,000 people throughout the world have been working on the Rosetta program, an almost impossible mission. The launching took place on March 2, 2004, and after a 10-year journey, a robot landed on a comet for the first time in history.
How exciting, how unbelievable to be able to dare to land on a comet.
We are the first to have done that, and that will stay forever.
Hollywood is good, but Rosetta is better.
The French National Center for Space Studies in Toulouse is home to the CENC, the Center for the Navigation and Control of the Scientific Mission, where a special team watches and chaperones the mission's two robots, Rosetta and Philae, 24/7.
We send robots into space because a robot costs between 100 and 1,000 times less than a man. 95% of the missions don't return to Earth. The only ones that do come back with samples, and they are very rare. And so, we execute primarily robotic missions.
Philae's descent lasted 7 hours, and the lander touched down 100 meters from the projected site.
We weren't able to determine at what moment we would land and under what conditions, and so there was an electronic brain on board capable of making certain decisions as to the best time to land, giving it a certain degree of autonomy.
An insufficient degree of autonomy since the electronics weren't well developed enough, having been created around the year 2000. At the moment of contact with the comet, Philae's anchoring harpoons and its boosters did not function, and the robot bounced like a tennis ball once, then twice, after which it flew above a crater and bounced a third time, before setting down between two rocks about 1.5 kilometers further on. To avoid this kind of problem millions of miles from Earth without any possible intervention by engineers, scientists are now working on much more precise landings. We head for the Thales Alenia Space Laboratories in Turin, Italy, where the initial tests of an exceptional Mars landing scenario are being carried out. For the first time, the robots are equipped with cameras. The images are analyzed in real time by an algorithm that indicates, without the intervention of an engineer, the best site for landing. This technology, which is used on Earth for drones, has never been validated for space.
This is very important for us for future mission to have, we can say, a new sensor on board that is like an eye for us. Is a camera. Up to now, no mission on Mars used a camera for landing. In this way, using a camera and the software evaluating the picture, we can reach much higher precision in the landing. Just one-shot mission. In case of trouble, we lose the mission.
And millions or perhaps billions of euros as well. In sending landers, space agencies have learned how to land even if the danger of a crash is very high. Scientists, therefore, wanted to go a step further by sending rovers to the Moon and to Mars. All sorts of machines have been imagined to counter the exceptional constraints of a different gravity from that of Earth, temperatures ranging from -140 to +30 degrees Celsius, corrosion and radiation. After the rovers were created, engineers equipped them with ultra-sophisticated options. Rovers have thus become portable laboratories, capable of taking samples and observing elements through a microscope. The first rovers landed on the Moon during the 1970s. 30 years later, they landed on Mars. Since 1997, 4 rovers have been moving around the red planet.
In the final years of the 20th century, we began to launch the first Martian robots, including a very important one called Pathfinder. It was about this high and was already on Mars in 1997. Thanks to Pathfinder, we realized that to thoroughly explore Mars, robots had to move and drive around the surface. The terrain was so diverse, we had to see each rock, each stone, to learn where it came from, how it was created, and why it was there. This realization encouraged NASA, the leader in this area, to develop bigger and better rovers, which in France are called astromobiles. And so after Pathfinder came Spirit and Opportunity. These robots, which landed perfectly in 2004, were designed to function for a few months, covering a distance of a few kilometers. Opportunity is in fact still in operation after more than 10 years, and after having traveled 40 kilometers. It has therefore surpassed its life expectancy, making some very fascinating discoveries.
Back to Turin in Italy. Thales Alenia Space is the principal project manager of ExoMars, the first European mission to the Red Planet. With a budget of 1.2 billion euros, the challenge is immense. In a few weeks, the first robots will be launched after a 2-year delay.
The mission is a very challenging mission. Sending a rover on the Mars is the first time that Europeans send a robotic element on another planet.
The Schiaparelli module should land on Mars in early 2016, entering the atmosphere at 21,000 kilometers an hour, after which a parachute will open to slow down the capsule, which will descend at Mach 2, twice the speed of sound. The deceleration will last 8 minutes before landing gently in the Meridiani plain at less than 15 kilometers an hour. In 2018, the scenario will be the same, but this time a rover will be released in the direction of Mars, making it the first European astromobile on the planet.
Other challenging thing is to control the rover on the soil of Mars, because we have not to forget the time delay. I mean, the signal coming from Mars could take up to 20 minutes of delay. It means that what we see on the screen, it is 20 minutes late. So when we plan the operation, we have to consider that what we see is already happened on the soil of Mars. In order to have the signal, we have a satellite orbiting around Mars. So the signal has to be sent from the rover to the satellite and from the satellite to ground.
This is why for Thales Alenia Space's Martian lander, engineer Ciro Napolitano is working on the software which will be installed aboard the rover in 2018.
We've programmed this vehicle which we're going to use to travel around the Martian soil. It was designed to surmount obstacles such as rocks and to explore the terrain. This is our control station. In the center, we can see the rover with its wheels. There are 2 parameters, the speed and the angle. On Mars, this rover's maximum speed will be 5 centimeters per second. We use 3 centimeters per second for testing purposes.
An extremely slow speed, averaging 180 meters an hour. The rover is therefore the most expensive and the slowest vehicle in the world. This is perfectly normal, since on Mars, it will be impossible from a distance of 350 million kilometers from Earth to repair it, should it get stuck in the sand or break down. The hope is that it will be as effective as Curiosity, the American super rover, which cost $2.5 billion and which landed on Mars in 2012 after an 8-month journey. It's the largest of all the rovers designed by NASA. And its successful landing was hailed by scientists as well as the American public. Curiosity is a very large rover, 3 meters long, 2 meters 70 wide, and 2 meters high. It has 6-wheel drive and a nuclear battery supplying the energy. It has been traveling around Mars for 3 years, making extraordinary discoveries.
We discover a new landscape that no one's ever seen before every day. It's a geological robot. We're sending the power of a nuclear reactor in 1 square centimeter.
No less than 7,000 people worked on the Curiosity robot. It's 4 times heavier than NASA's 2 previous Martian rovers.
And instead of an 8-kilo payload, it will have a 90-kilo payload. That's huge. It's a scientist's dream. What makes this object so valuable are the scientific instruments. The fact that it's on wheels, that it has antennas, a source of energy, and cameras is important, but the true value for science is its scientific payload.
Among the scientific instruments aboard Curiosity, 2 are French. The SAM, a mini laboratory for analyzing the soil, and ChemCam, a laser camera, the only one of its kind in the world.
It's a technique that enables us to determine from a distance the composition of the rocks and the Martian soil. A laser sheds its light on a rock by creating a plasma or a small 8,000-degree light, a little spark. Then, with a telescope, and by decomposing the light of this plasma, we can tell if the rock is made of iron, sulfur, titanium, barium, lithium, or even hydrogen. The ChemCam is the eye that recognizes the rocks and guides the rover. After 3 years of this mission, we've fired more than 250,000 from this rover.
Every day, 100 people throughout the world get together for a huge telephone conference call in order to organize the robot's work plan.
We have to come up with a priority here if we want to do that for our plan.
So analyzing broken rocks, I think, is a rare opportunity we should not miss.
Tonight in Toulouse, the ChemCam team is preparing to fire at 3 particularly interesting Martian stones. The objective, in cooperation with NASA, is a 45-minute series of laser firings.
We're in business now. We requested 3 targets, 3 rocks on which we'll fire 30 shots each, making 150 laser firings, 3 times for each. We've therefore programmed 450 firings. Now we have to refine everything, including the coordinates of the targets, determining where the sun will be at the moment we fire and where the arm is. It's not a question of firing above if it's deployed. The rover's stability, its incline, the resources we need in terms of energy, and the telemetry will determine our ability to repatriate the data generated by the rover. We'll be working on the resources, security, and the operation as a whole. It's not just the Americans. There are about 100 of us here guiding the rover, and each of us gives his instructions, and we'll try to organize them into a comprehensive plan to place aboard in the next few hours.
NASA has given the green light, and so it's time to program ChemCam's 450 laser firings.
We have 135.4 meters until our next sun update.
Everything is in fact centralized at NASA in Los Angeles. We'll send them our files tonight, and they'll put all the files for all the instruments into a huge computer. Once the package is full for the entire day, the program is sent to the robot on Mars. It will execute the programmed sequence when it wakes up tomorrow morning. There are only 6 of us in the world capable of digging holes on Mars, and we're all at the CNES in Toulouse. We're fortunate in that we're pioneers, digging the first holes on a planet we're exploring. It's the chance of a lifetime.
A unique chance as well for 2 other French teams dealing with the SAM. This instrument is in fact an ultra-sophisticated laboratory consisting of a spectrometer which analyzes the molecules, another instrument for chromatography which separates them, and 74 mini-ovens. In short, the SAM analyzes the samples from the Martian soil. And it's the SAM, in fact, that confirmed the presence of water on Mars.
Thanks to all of Sam's instruments, the laboratory made this discovery. After heating the soil sample, we understood, and by putting all the data together, we discovered that at one time on Mars, on the site where we are now, there was a lake. It wasn't a huge surprise, as we were expecting it, but the lake was fairly shallow, and it was a freshwater lake, no salt, no acid or mud, and so the water was drinkable. By a lake we mean a dense atmosphere, something which lasted an indeterminate amount of time with an environment reducer, that's a bit technical, with sources of carbon, hydrogen, nitrogen, sulfur, phosphorus, all of which could one day create life. By putting these physical and chemical parameters together, we can conclude that Mars was once livable. That is an enormous discovery, because only 2 years ago I was convinced that the only planet in the solar system that could sustain life was Earth. And now I can say of the 8 planets, 4 telluric and 4 giant planets, that in the history of our solar system there were 2 habitable planets, probably at the same time, Earth and Mars.
During future missions to the Red Planet, scientists will try to study the subsurface. The common goal, in fact, of NASA and the European Space Agency is to dig 1 or 2 meters deep in order to search for traces of life, elements sheltered from cosmic rays and protected by the layer of Martian soil. To do so, however, requires an incredibly powerful drilling machine. We head for California and Honeybee Robotics, a company that has been working with NASA for 20 years. Most of their equipment is aboard American landers and rovers. At the moment, they are preparing for the next Mars mission scheduled for 2020 by trying to perfect a deep drilling technology especially designed for Mars.
So this drill has been designed to capture samples from at least 1 meter depth on planetary surface. Initially it was designed for exploration of Mars. Mars sees a lot of radiation, so in order to capture microbes, you have to go at least 1 meter down where they have been potentially preserved in the subsurface.
Thanks to this invention, scientists should be able to obtain rock samples that have not been exposed to radiation or cosmic rays, and perhaps find traces of life.
Instead of a drill that captures powder at the end of the arm, it will have a coring drill to capture rock samples, put them in a cache, and deposit the cache as the rover traverses the planet. And then, after that mission is done, it's going to take a couple of years, there's going to be another mission. It's going to go in and pick up some of these rock samples, sort of like a breadcrumbs that's sitting on the surface of Mars. It's going to cache them, put them on top of a rocket. That rocket is going to launch these rocks around the Martian orbit, and then there's going to be another mission. And that mission is going to capture these flying rocks and bring them back to Earth. We're thinking it's going to probably take 20 years before we see those rocks.
For us, the prize is bringing back these samples from Mars, going to Mars, collecting samples which could prove that life once existed there, and bringing them back to Earth, and afterwards determining if this life is based on DNA like ours or not, which is a huge question mark. If we can answer this query, we will have a different vision of how life first appeared. The only example we have now is life on Earth. The day we have a second example, we can begin to generalize on how life appeared in the universe.
This precious information is attainable for us, or rather for robots, although it will require even more perfected and more multi-purpose machines. Martian rovers are becoming more and more sophisticated, greatly increasing our knowledge, trying to answer questions such as, does water still flow on Mars? Could this planet be habitable? Was it once inhabited? Questions which have troubled scientists for years. To answer them, new kinds of robots will have to be invented and deployed. After the rovers, which belong to the second family of space robots, we have co-robots or cobots, designed to work for or with man. A new era is on the horizon, representing an unprecedented cooperation in the history of humanity. Everything has changed in less than a century on Earth as well as in space. The technological revolution has shaken our era to the point where everything seems possible today, even in the infinity of the universe. First, there were scout robots, the first space adventurers. Then came laboratory robots with rovers that moved around the planets. And now the adventure continues with collaborative robots, cobots, which space agencies will be sending to today's objective number 1, Mars, the closest planet to Earth, its twin sister. Recent discoveries have motivated scientists even further.
Give me a ticket to Mars and I'll leave tomorrow.
Tomorrow, of course, is not a reality for man. Mars is still too far and too dangerous a destination for astronauts. No one has up to now been able to master the technique for such a mission, although preparations are underway. Space agencies throughout the world are working on the possibilities, although not only for man. All over our planet, scenarios for living on Mars are being tested. According to specialists, in 20 or 30 years, technology will be advanced enough to send men to Mars or place them in orbit around Mars with the help of new companions, cobots, without which such missions would be impossible.
Once we've sent men there, we'll need robots to perform the menial repetitious tasks, so as not to waste human time, and also for tasks that are too difficult or too dangerous.
More complex than simple rovers and more autonomous and intelligent, these robots will work in perfect harmony with highly trained astronauts.
Space is a very tough environment. There's nothing that is really very good for man's health, so we need to have some machines to go there and to do some parts, at least, of the exploration.
In the future, then these robots can prepare simple human tasks and prepare the imminent of humans on a planetary surface.
In our lab, we work in a very nice interplay between engineering and biology.
Cobots resistant to radiation, extreme temperatures, and the void will be able to work side by side with the astronauts. Scout cobots, resembling animals, or cobot technicians capable of preparing the habitation bases, represent an essential step for man's survival in our new conquest of space, aiming higher and higher still. Lausanne in Switzerland is home to the Polytechnic School, which includes 5 universities, 350 laboratories, and almost 10,000 students from about 100 different countries. There are very few laboratories like this one in the world, where animals are filmed and x-rayed in order to understand their locomotion techniques, after which scientists try to apply them to the interior of robots.
It's very expensive to send something out of space, so that means that you need to embed in these machines a lot of possibilities to move around, to recharge the batteries, and to perform better. So I guess the multi-locomotion capability that robots inspired by animal provide us are one of the key factors for space exploration.
Another example is this salamander robot. Amphibians are interesting because they can live both on land and water and can adapt to either environment. This is exactly what interests Camilo, whose robot copies the way a salamander moves thanks to 11 motors in the robot's spine and 16 others in its feet.
So we have this sprawling posture, so basically we can access some places that other robots cannot. So for example, we can pass underneath very, very tiny passages like this. So with this posture, we can do that kind of things. At the same time, with the same robot, remember these multi-locomotion capabilities, we can also swim with this kind of robot because we have the whole spine adapted for that thing, and we have the fin for the same reason. The problem is performance. If you go to space and you want to travel 10 kilometers in the surface of a planet, for example, of course this robot is not the best for doing that. I guess in that case wheels are better. But if the wheels can take this robot to some other place where you can go for a focus task, I guess the robot is perfect. So I guess the combination of the two robots is the key to really go to space exploration, in this case for planetary exploration.
Multifunctional and organically inspired robots are also being developed in Bremen at the Center for Robotic Innovation. This North German city possesses numerous space robot laboratories, and especially the DFKI, specializing in artificial intelligence. Scientists are working on a variety of programs in cooperation with German and other European space agencies. In the laboratories, we run into humanoid robots like Isla, or animal robots such as Istruct, Krex, and Mantis. We now head for the Institute's clean room, where Project Limes is being conducted, consisting of tests on a gigantic praying mantis.
I want you. That's a six-legged walking robot, and which is also capable to lift up the front body to be able to manipulate something with its front legs. And what they require for planetary exploration on Moon or Mars is they need systems which are capable to traverse very unstructured surfaces. And then if they are able to traverse the surfaces, they also have to be able to perform some manipulation tasks in the area which they are capable to reach. So, for example, to collect samples, or also to maintain or set up infrastructure on these surfaces.
The project is funded by the German Space Agency, which considers this robot insect a key to future missions on Mars or the Moon.
If you really have a look at the mantis, then the mantis is I think, the only insect which is really capable to perform more or less precise manipulation tasks.
The RMC, the German Space Agency's robotic laboratory, is located in Wessling, near Munich. There are articulated arms everywhere, mounted on different types of robots, humanoid robots or rovers. Specialists are trying to determine the best man-robot interface to command them. Some prefer the joystick, others the exoskeleton. The goal is to command these robots in real time on the lunar or the Martian soil. Robots capable of reproducing the movements of the astronauts sheltered safely in their base. Only the scenario is tested here. For 20 years, DLR engineers have been developing the technology for robotic arms. In recent years, they have designed a hand with 4 fingers, since the 5th serves no purpose and is more expensive to manufacture. At present, they are working on a robot controlled by another robot.
To get ready, I use 2 different systems. First, a glove with sensors that enables us to measure the position of the fingers, and which will be used to manipulate the hand by remote control. I also use a man-machine interface to which I attach myself, and which allows me to send orders to the robots, like the position I want to reach, and also to feel what the robot feels, since this robot will either push or pull my hand based on what the distant robot feels.
The energy feedback is what enables astronauts to command a robot with more finesse, thus avoiding any equipment damage. And at the heart of a space vessel or base, this is essential.
By hitting this pedal, I can feel the robot moving from a distance, and I can direct it. If I enter into contact with the environment, I can feel on this robot here an energy feedback at the level of the wrist, which makes it easy for me to look for contact with certain objects. I can feel the force that I apply to this button. If it's too hard, then there's definitely an error, and I can stop it and take the time to think things out. Conducting a mission outside of the International Space Station This is very dangerous and costly, and there are several tasks that even a simple robot can execute, such as manipulating the switches or checking that a valve is shut tight. It's work that can be prepared in advance before the astronaut arrives on the site, and that can save a lot of time.
Space Justin is scheduled to arrive at the ISS in 2020 and join Robonaut 2, the American robot. To work with the astronauts, all of the space agencies prefer to develop robots with a human shape, and the reason is obvious.
We don't want to scare the humans off. If we build a robot that looks like a Terminator, you know, with red glaring eyes and metal face, it will be just a psychological problem for humans to interact with these kinds of machines. So that's why we gave Ayla also a female shape, because we had all these humanoid robots in the world. They are all strong Terminator kind of robots, and we said, okay, we do it a different way. We give it a more nicer shape.
Humanoids are veritable cobots or collaborator robots. They can open up a valve, an airlock, press a button, but they can remain in orbit around the base, at least in the beginning. It will be necessary to send animal-type robots or rovers which have proven their reliability on the Martian or lunar soil. Equipped with robotic arms, they can be deployed for general tasks, building places to live or assembling structures. These highly autonomous machines will be able to learn about the terrain thanks to algorithms of artificial intelligence. We now go to Holland and the European Centre for Space Research and Technology, situated between Amsterdam and The Hague. The teams working in the Telerobotic Laboratory are preparing an experiment unique in the world. A rover with 2 arms will be guided by remote control from the ISS, the orbital station located 400 kilometers above our heads.
So it's preparing the future of exploration missions that make use of humans in orbit of planetary bodies and robots on the surface to project actually the human presence into the robot onto the surface. Our technology actually enables robots to do this, remote controlled by humans, in a very interactive and intuitive way.
Aboard the ISS, Danish astronaut Andreas Mogensen will be required to use a joystick with energy feedback to directly command a robot. The rover has to simply insert a metal tube into a structure, but it's a lot more complicated than one would think.
This pin, it only has a tolerance of about 100 to 150 micrometers to the hole. So when you try it yourself, you see how easily it actually jams. If you have like a small misalignment from it, then you can't insert it, in fact. It has to be totally precise.
For this experiment to be successful, one has to rely on one's senses.
The innovation of the force feedback is important because it enables astronauts in orbit to actually feel what a robot does somewhere else, either in another location in space or on a planetary surface. And this way he can do tasks very naturally as if he would be present physically at that site. So if you imagine handling a raw egg or actually doing very complex tasks like lacing your shoe or inserting a connector in the back of your TV set, these are all tasks that require you to feel the geometry. And what we transmit here is exactly this feeling. So it helps him to accomplish this complicated task.
The experiment reproduces a scenario which could take place in a few years between a rover on Mars and a space station orbiting around the planet. In the ISS, which navigates at 28,000 kilometers an hour, the Danish astronaut has less than 1 hour to carry out the experiment, with no knowledge of interface or joystick, and who has never piloted the rover.
Our robots actually transmit this sense of touch to the human operator, and we are the first time in the history of spaceflight to actually extend this sense of touch over distances between space and ground or between space and any planetary surface.
The success of this type of experiment allows specialists to project themselves into the future and imagine the construction of bases in outer space. On Mars for NASA, on the Moon for the European Space Agency, which would like to set up a village to replace the ISS when it ceases operations in 2024.
Once we've landed men there, it becomes a habitat. The work around the habitat entails a minimum of 10, 15, or 20 tons. We don't know how to do it, but we're working on it. We think that the first man-Martian flights will be flights where man remains in orbit. In order for man's presence to be effective, we feel that they should be able to command robots on the surface in real time by remote control. We can't do this from Earth because of the distance, which prevents us from telecommanding in real time, like an airplane pilot who can push a button and immediately activate his joystick. We've got to be able to do this while we're orbiting Mars.
After the cobots, which will assist men during their extraplanetary missions, a fourth family of robots will be more and more vital. Protean robots, which can serve as refuse collectors, skilled workers, or shuttle pilots. In 10 or 20 years, man will live in outer space thanks to all sorts of robots. This is not a utopian concept, but an opportunity that space agencies and private companies want to seize, since space is becoming a new multi-billion-dollar business. We've come a long way from the Star Wars era, when the United States and the Soviet Union were the only nations in outer space. Today, dozens of space agencies throughout the world, as well as private companies, are developing systems to study the cosmos, work on other planets, and send robots or satellites there. After the reign of the scout robots, followed by laboratory rovers and cobots, there is one final category: robots whose role it is to clean up outer space. Once completely devoid of debris before the launching of Sputnik, space has been filling up at an alarming rate for the past 60 years. Today, there are 1,000 or so satellites in operation and 900 more to come in the next few months, in addition to space debris and the billions of meteorites circulating at the incredible speed of 30,000 kilometers an hour.
A 1 millimeter in diameter debris has the same energy as a bowling ball launched at a speed of 100 kilometers an hour. In the long term, if nothing is done, it's possible that the space infrastructure will become unusable.
The international community is working on a global solution to combat this debris, which increases exponentially every year, threatening satellites that are a useful part of our daily lives. Outer space, therefore, will have to be cleaned up using a new type of robot, so that the debris doesn't fall on our heads one day.
We've catalogued objects of this size re-entering the atmosphere on a daily basis. We have a large satellite or a large satellite stage re-entering at a rate of 1 per week. And when they re-enter the atmosphere, they heat up enormously, slow down, and break up. Does everything burn? No, not everything. 10, 20, or even 40% of the mass can survive and thus impact the surface of the Earth. The primary danger of this debris is the possibility of a human victim. The second and more immediate danger is for a satellite operator. If you launch a large satellite, there is a 5% risk of it dying before its time as a result of a collision with space debris, creating a direct financial impact. The third danger is in the long term. Occasionally, two large objects collide, such as was the case in 2009 between Cosmos 2251 and Iridium 33. Such a crash generates about 5,000 large pieces of debris. The multiplication of debris due to collisions makes us a bit wary of the long-term future.
Dozens of more or less eccentric projects are being imagined by engineers to gather the debris and eliminate it. One such idea is based on the concept of spearfishing. Another is using navigators with a huge self-folding sail. Then there's the Star Wars technique with laser fire, or the bombarding of ions. There's an even more surprising technique using flypaper, or even deploying a huge net. Finally, there's the medical technique with a clamp fixed onto a hunter robot. Each method has its advantages and disadvantages, but the most common strategy among manufacturers is that of a robotic arm mounted on a hunter robot. This is the technique being developed by the engineers at Airbus Defence and Space in Bremen. Equipped with a 3D sensor for seizing all sorts of stones as if they were lost debris in space, the robotic arm's capacity is being tested in the Airbus laboratory.
We have fairly similar technologies for captures in orbit and for seizing objects on a lunar or Martian surface. Here, we have a three-dimensional sensor. We're trying to combine an autonomous and a manual approach with this system, because in any kind of space exploration, communication time between the Earth and distant heavenly bodies is fairly long. And so, if we try to do it all manually, each operation will take a very long time. What we want to do now is to have an autonomous system, meaning that it's capable of selecting objects on its own, calculating their position, and seizing them, giving us great operational flexibility. For this experiment, we have a sensor with 3 pinchers for relatively simple objects, like stones. When we switch to the debris system in orbit, we need more complex interfaces, and we're developing a system capable of seizing the orbital debris using a complex geometry.
At present, there is no international legislation requiring companies to remove their debris from outer space. Cleaning up space, however, is becoming necessary since every year the increasing amount of debris threatens satellites in orbit above the Earth. Robots, which cost a total of more than $100 billion, are also threatening this new outer space business. One such business, Swiss Space Systems, or S3, is located in the Swiss city of Payerne. S3 wants to send small satellites into space for 10 million euros, 4 times cheaper than its competitors. Their secret lies in reusable technology with an entirely automatic aircraft and space shuttle. Once the right altitude is reached, the shuttle releases a capsule in which satellites have been installed. The shuttle then makes a gentle landing without a pilot.
Today, the SOAR is sized to launch satellites weighing 250 kilos in heliosynchronous orbit, or SSO, at an altitude of 700 kilometers. This represents tomorrow's satellite market. They're what are characterized as small satellites. Today, we're witnessing a paradigm shift in the area of space satellites. We're going from huge satellites, launched in geostationary orbit at very high altitudes, like 36,000 kilometers, to a range of smaller, lighter, low-orbit, and especially low-cost satellites.
The shuttle should be assembled in 2016, with tests beginning the following year. By that time, a new rover will have reached the moon. In 2007, Google launched a $30 million public competition with the goal of sending a robot to the moon, a rover capable of moving over an area of 500 meters, taking high-definition photographs and sending them back to Earth. 6 teams from 13 different countries participated. This represented an initial challenge before sending men to the moon once again.
I think one of the reasons why big companies are deciding to invest in what we call new space technologies is one, because they like to think big, but they also see a solid business plan and they know that businesses can be developed out of this.
In America, captains of industry are investing huge sums since they know that outer space is today's new El Dorado. Throughout Europe, Asia, and Africa, men want to conquer space, walk in the footsteps of Yuri Gagarin and Neil Armstrong for the beauty of the experience, of course, but mainly for the dollars they can earn. It's a sound investment. €1 invested in space will increase by 5, since on the Moon, Mars, or the stars, there's iron, cobalt, nickel, silicate, platinum, as well as new sources of energy. Experts estimate that this business will entail hundreds of billions of dollars, further motivation for man to look upwards in a different manner.
To save the human race, there is only one solution: learning to live on other heavenly bodies.
In just a few years, the use of outer space will become part of our daily lives, and the wealth contained in the stars will inexorably compensate for the depletion of our natural resources on Earth. People will live and work on the Moon, on Mars, or on orbital space stations. And this new conquest of the infinite can only succeed with the help of even more effective and autonomous super robots.